Hey everyone, let's jump right into this explainer and decode the foundational mechanics of Python 3.14.7. We're going to take standard documentation and turn it into a real journey exploring how this language actually operates under the hood. Whether you're scripting simple automations or architecting massive systems, mastering these fundamentals completely changes the way you write and read code. So at its core, how does Python actually think? I mean, sure, a program is ultimately just a list of instructions running one after the other. But today, we're going to explore how we can make those instructions smart, structured, and incredibly elegant. We aren't just looking at what the code does. We're looking at how Python processes it, isolates it, and scales it. To get there, we'll follow a pretty natural evolution. We're starting with mastering simple statements, then directing control flow, unlocking pattern matching, defining reusable functions, tackling advanced function arguments, and finally, getting an introduction to classes. All right, Section 1, Mastering Simple Statements. These are your building blocks.
Think about the import statement for a second. We use it all the time, right? But it's definitely not magic. When you write an import statement, Python actually executes a really strict three-step process. First, it searches to find the module, then it loads and initializes it if necessary, and finally, it defines and binds those names into your current local namespace. It's a highly coordinated operation just to bring external tools into your workspace.
Now, when you need to manipulate those bindings or maybe just hold space in your code, Python gives us two totally different tools. The del statement aggressively removes name bindings from your local or global namespace. And, by the way, if you try to delete something that isn't actually there, it's going to throw a name error. On the total opposite end of the spectrum, we have the pass statement, which is just a silent, null operation. When it executes, literally nothing happens. That makes it the absolute perfect placeholder when you're sketching out functions or classes but just aren't quite ready to write the logic yet. Moving on to Section 2, Directing Control Flow. This is where we add some intelligence.
Okay, before we can loop through any data, we really need to understand what an iterable is. Basically, it's a target that supplies successive items until its supply is completely exhausted. When you use a function like range, you aren't just creating a massive list in memory. No, it actually creates an iterable object that yields the next number only exactly when you ask for it, which saves an enormous amount of space.
So here's the crucial point. Python's for loops iterate directly over the items of these sequences in the order that appear, while while loops run as long as a condition remains true. But here is one of Python's most brilliant hidden features. You can actually add an else clause to your loops. This else block acts as a reward. It only executes if the loop finishes entirely naturally, without ever hitting a break statement. It's incredibly useful for search operations, where you need to know if you made it through the whole pile without finding what you were looking for.
Let's hit Section 3, Pattern Matching Unlocked. Think of this as the mail sorting room. Structural pattern matching is honestly a real game changer. It brilliantly illustrates how standard, cluttered if-else chains can be completely replaced. Instead of repeatedly checking values against constants, a match/case statement doesn't just check for a match. It actually unpacks and binds variables in one smooth motion. So if you pass it a coordinate, like a point, it can confirm the structure and simultaneously extract the x and y values into fresh variables for you to use immediately. It's so clean. And of course, if absolutely no specific patterns match your incoming data, Python has your back with the underscore wildcard. The case underscore acts as this ultimate foolproof fallback. It never fails to match, ensuring your program can gracefully handle unexpected data without just crashing on you. All right, Section 4. Defining reusable functions. Let's build the assembly line. So when you execute a def statement, sure, you're creating a function object. But more importantly, Python is literally setting up a brand new, fresh local symbol table for that function. This means that all the variable assignments happening inside your function are safely isolated. They look in their own local table first, ensuring your function's inner workings don't accidentally contaminate the global variables of the rest of your program. Now listen up, because this is an absolutely crucial warning straight from the documentation. When you define default values for your function arguments, those values are evaluated only once, right at the point of definition. If you use a mutable object, like a list or a dictionary, as a default argument, it'll retain its state and share that exact same list across all subsequent function calls. If one call appends to it, the next call sees that addition. This is a massive headache if you aren't expecting it, which is why it's always safer to use none as your default for mutable objects. Next up is Section 5, Advanced Function Arguments. Time for some precision control. When you're looking at a function signature, you might occasionally spot a forward slash or an asterisk. These enforce some highly technical parameter rules. Use the forward slash when you want to enforce positional-only arguments. That means the user cannot use keyword names, which is actually great if the parameter names don't really matter and might change in the future. On the flip side, use the asterisk when you want to force explicitly named keyword-only arguments. That ensures the caller is crystal clear about what data they're passing in. But wait, what happens when we don't know exactly how much data is coming in? If you want to accept an infinite, arbitrary amount of input, unpacking with asterisks will seamlessly do the heavy lifting for you. Using star args will scoop up all the remaining positional inputs and roll them right into a tuple, while star kwargs will take all the named keyword inputs and beautifully pack them into a dictionary for you to iterate over. Right before we hit our final structural tier, let's take a quick detour and talk about PEP 8. Because, writing code isn't just about making a machine understand you, it's about making humans understand you. PEP 8 provides these standard best practices, like consistent indentations and naming conventions, that take your code from a chaotic pile of instructions into a clean, professional, and globally readable structure. Finally, we arrive at Section 6, Introduction to Classes, the Factory Blueprint. To really wrap our heads around classes, we first need to quickly define namespaces. Think of a namespace like a mapping from names to objects, acting a lot like a room directory. We've got the built-in namespace that never dies, the global namespace for your module that lasts until the script ends, and the local namespaces for functions that are created and destroyed as they run. Classes introduce entirely new, dedicated namespaces to keep our data perfectly organized and safely isolated. And tying right back to our earlier control flow chapter, we've got iterators. These are basically the invisible engines powering loops both inside and outside of classes. They're the underlying objects representing streams of data, quietly returning successive items until an exception called stop iteration halts the whole process. Now, when you want to create those iterators easily without having to build massive custom classes from scratch, you build a generator. It looks just like a normal function, but instead of using return, it utilizes the yield statement. This smartly pauses execution and saves all of its local state, all those local variables, and exactly where it left off. That's so much better than destroying the local symbol table like a normal return statement would. It is incredibly memory efficient. Bringing this all together, classes really act as the ultimate blueprint. They seamlessly bundle those namespaces, those generator functions, and your structural data into one cohesive, reusable object. When you create a new class, you're creating a completely new type of object in Python. That allows you to generate endless unique instances, with each one maintaining its own state through attributes and modifying that state through methods. So, we fully unpacked the tools of Python 3.147 today, moving from the micro-level logic of simple statements all the way to the macro-level architecture of object-oriented classes. These features are undeniably powerful, but they leave us with one vital question to ponder as we close this explainer out. With all these elegant structures at your disposal, are you writing code that merely runs for the machine, or are you writing code that truly communicates your intent to the world?